I will now explain example 2 on page 127. We are given an open box in the shape of a rectangular prism, and we are giving the length as x centimeters, the volume 480 cubic centimeters, and the breadth is 4 centimeters. And they ask us to determine the height in terms of x. So you need to remember this formula: volume is equal to L times B times H. And we can substitute the values that were given. 480 is equal to x times 4 times h. This is the unknown. If we simplify this, we end up with a formula that looks like this. 480 is equal to 4xh. If we divide on both sides by 4x, this will make h, the subject of the formula, equal to 480 over 4x. Following, they are asking us to write down an expression for the total surface area of the box. Now here it's important to remind yourself that the box is open. I brought an example of an open box, so there's no top, and then we have the other side. So over here we see the length, the height, and the breadth, and the top is open. So if we write down an expression for the surface area, we will write down L times B, and this is going to represent the bottom only. But 2 times L times H, this will represent the front and the back of the box, plus 2 times B times H, the breadth, times the height, gives us the left and the right hand side of the box. And I can first substitute into this expression the values that I know. L is 4, B is x. I'm sorry, it's the other way around. That gives me 4x. 2 times the length is L, the height is 480 over 4x, plus 2 times the breadth is 4, and the height is 480 over 4x. And I can simplify each term of this expression and end up with 4x plus 240. So over here the x and the x cancelled out. The 2 and the 4 cancelled out, and 480 divided by 2 then is 240. And over here the 4 and the 4 will cancel out. So I'm going to multiply 2 by 480, it gives me 960 over x. This is an expression for the total surface area of the box. The next step, they ask us to calculate a value for x that will make the surface area of the box a minimum value. And we learned in the previous video that we find minimum and maximum values at the place where the derivative is equal to 0. So we would like to find an expression for the derivative of the surface area. But first of all, we need to rewrite this term in exponent form, because when we are finding the derivative, we did not learn a rule for a fraction. So we write it as x to the power of -1. After we did that, we can find a prime, the derivative. This term is just going to be 4. This one is going to fall away completely because it's a constant. And over here I will say -1 times 960 is minus 960. Then I subtract a 1 from the exponent. It gives me x to the power of -2. And I substitute a 0 for the derivative because we're looking for a minimum value. So each time that you are asked to find a minimum or a maximum, you will make the derivative equal to 0. X to the power of -2 is a fraction again. I can rearrange to make a fraction. And after this step, I can simplify by multiplying each term with x squared. It gives us still a 0 on this side, 4x squared over here, and over here we have 960, the x squared and the x squared cancelled out. Still rearranging, I can say that 4x squared is equal to 960. Divide on both sides by 4. X squared is equal to 240. Now I'm going to find the square root on both sides. And each time that I find the square root, I always need to write down plus minus. There are always two solutions to a quadratic equation. So the square root of 240 on your calculator, 15,49. But since we are calculating a length, we just use the positive value. The last question was to find the actual minimum surface area. So we're going to substitute the calculated value for the length into the expression that we found earlier for the total surface area of the box. So over here I substituted the 15,49 into this term and also into this term over here. Calculate on the calculator 363,494 square centimeters. So the most important things to remember, it was an open box, so we are not going to have a top part. I need to remember the formulas for certain properties of a 3D shape. I wrote h as in terms of x. I substituted values. I remembered to write in the exponent form. I found the derivative and made it equal to 0. It made it possible for me to solve for x, and this I substituted back into my earlier equation to find the actual minimum surface area that I need.